Bismillahirrahmanirrahim. In this session, we will discuss the topic sound from O-level physics book written by Tom Duncan and Heather Kennett, published by Hodder Education. Sound waves are produced by vibrating source. So sound waves are always produced by some kind of vibrating source, whether from the vibrator in our vocal cord, or a violin string, or a loudspeaker. All the speech, music, and noise we hear around us are transmitted by sound waves. All the speeches, music, and noise we hear around us are transmitted by sound waves. Like waves on a spring, sound waves are longitudinal waves. Sound waves are longitudinal waves, and they require a medium in which to travel. So these waves require a medium to travel. The speed of sound varies strongly between the material from around 340 meters per second in air to 1500 meters per second in water. So the speed of sound is much higher in water as compared to air. Sound waves have many of the same properties as a transverse waves and can be reflected as in echo and refracted and diffracted. Reflected sound waves used in sonar depth sounding at sea can locate the position of a shoal of fish. So reflected sound waves used in sonar depth sounding at sea can locate the position of shoal of fish. This is the one of the application. Ultrasound with frequencies above the range of human hearing, around 20 kilohertz, more than 20 kilohertz, is used for sonar and medical imaging. Ultrasound is used for sonar and medical imaging. Do you have some jewelry you would like to clean? Ultrasonic cleaners are also available, can help remove the dirt. Similarly, the origin and transmission of sound. The source of sounds all have same part that vibrates. So sound waves are always produced from the vibrating source. A guitar has a string, a drum has a stretched skin, and the human voice has a vocal cord. So all have a vibrator. The sound travels through the air to our ears and we hear it. That the air is necessary may be shown by pumping the air out of a glass jar containing ringing bell. The sound disappears after though the striker can still seen hitting the gong. Eventually the sound cannot travel in a vacuum as a light can. So sound cannot travel in vacuum, but light can travel in vacuum. A medium is needed to transmit sound waves. Sound waves always require a medium to transmit. In addition to air, solid, liquid are also able to transmit sound waves. So air can transmit sound, but solid and liquid also able to transmit sounds. Sounds also give interference and diffraction effects. Because of this, its other properties, we believe sound transfer energy as the damage for supersonic boom shows, which travel as a progressive longitudinal waves. As with the transfer waves, sound waves obey the wave equation. So wave equation is equal to wave speed is equal to frequency to wavelength. And the speaker has a cone. The loudspeaker has a cone which is made to vibrate in and out by electric current. When the cone moves out, the air in front is compressed, and when it moves in, the air is refracted, becomes thinner. The wave progresses through the air, but the air as a whole does not move. The air particles, molecules vibrate back and forth a little as the wave passes. When the wave enters your ear in the compression and rarefaction cause small rapid pressure changes on the eardrum and you experience the sensation of sound. So this compression and rarefaction on our sound eardrum gives the sensation of sound. The number of compression produced per second is the frequency of the sound wave and equals to the frequency of the vibrating loudspeaker cone. The distance between successive compression in the wavelength, the distance between successive compression is the wavelength. Similarly, the rarefaction, successive rarefaction is also a wavelength. As with the transverse waves, the speed is equal to V is equal to frequency into lambda. And test yourself, page 167. Describe how a sound wave can be produced. Sound waves are produced from a vibrating source, and whether from the vibrator in your vocal cord, violin string, loudspeaker, all the speak music noise we hear around us are transmitted by sound waves. Like waves on a spring, sound waves are longitudinal waves. They require a medium in which to travel. This is question number 1. Now question number 2, describe how the air molecule vibrates when a sound wave is transmitted in air. It's because of the compression and rarefaction. It happens because of compression, rarefaction of the material or of the medium. How far apart are the compression in a sound waves? The distance between successive compression is the wavelength. As with transverse waves, the speed is equal to lambda into f. Limit of audibility. The human hear only sound with the frequencies from about 20 Hz to 20 kHz. These are the limits of audibility in a healthy human ear. The upper limit decreases with the age. This limit decreases with the age. Limit of audibility, the approximate range of frequencies audible to the human is 20 Hz to 20,000 Hz or 20 kHz. Reflection and echoes. Sound waves are reflected well from hard, flat surfaces such as wall or cliff and obey the same law of reflection as light. The reflected sound forms an echo. An echo is a reflection of sound waves. Echo is a reflection of sound waves. If the reflecting surface is nearer than 15 meters, the source of sound, the echo joins up with the original sound, which then seems to be prolonged. This is called reverberation. This is called reverberation. Some is desirable in a concert hall to stop its sounding dead, but too much causes confusion. So reverberations are deliberately used in a concerts. Modern concerts hall are designed for the optimal amount of reverberation. Seats and some wall surfaces are covered with sound absorbing materials. The speed of sound in air. The speed of sound in air is approximately 330 to 350 meters per second. In other materials, the speed of sound depends on the material through which it is passing. It is faster in solid than in liquid and faster in liquid than in gases. Because the molecules in a solid and liquid are closer together than in liquid, and those in liquid are closer than the gas. So speed of sound in air is 330 to 350 meters per second, while in water 1400 meters per second, in concrete 5000 meters per second, in steel 6000 meters per second. So the speed of sound in steel is much faster than air. In air, the speed increases with temperature. If temperature increases, the speed increases, and at a high altitude where the temperature is lower, it's less than at sea level. Changes of atmospheric pressure do not affect. Pressure does not affect, but the temperature has some effect on the speed of sound. Measurement of speed of sound. An estimate of the speed of sound in an air can be made directly if you stand about 100 meters from a high wall or building or clap your hands. Echo are produced when the clapping rate is such that each clap coincides with the echo of the previous one. The sound has traveled to the wall and back in the time after the two clap, one interval by timing 30 interval with a stopwatch. The time t for one interval can be found. Also, knowing the distance d to the wall, a rough value is obtained. The speed of sound in air is equal to 2d upon t. This is a direct method. The speed of sound in air can be found directly by measuring the time taken from sound to the travel past two microphones separated by a distance t. So this is a start and stop. This measures time, and this is t is equal to 0. This is a t time when the sound reaches here. So this is one of the other experiment, direct method. So this kind of setups are used for direct measurements. That was the echo measurement, where the sound goes and travel back, so that's why it takes double distance. Yeah. We will use this in some numericals later on in this chapter. In the next section, we'll discuss musical notes.